Hey guys, I'm Nick, and today we are creating this kind of RBD disintegration, but I think there were so many RBD disintegration tutorials that I assume it's something a bit different. I initially found this on this Acer Concept D500 commercial done by Computer Face, and in their process and development, I found this animation. So I tried to kind of recreate the concepts that they used in their animation. Of course, mine is a bit different, but yep, let's dive inside Houdini and see what we got here. So as always, we will talk about the materials, cameras, and lights a bit later, so we can just drag it here. So our composition consists of the ground plane, our backplate, and some dust particles. Of course, we start with our box and just look at this. And don't be scared because basically, yeah, so I could write down some kind of like reverse subdivision, recursive subdivision algorithms, but to be honest, I want to keep this tutorial about RBD, not about like recursive subdivisions, because my tutorials tend to become a bit longer than I want them to be, and yeah, just good old polygonal, or I mean not procedural modeling is done here. So basically what I did is I added a bunch of boxes and yeah, then merged them all into, I don't know, into some sort of a rectangle here. So here's the deal. I made one part of the 5x5, or actually 10x10 grid or box, and then I did the same. I created that same box, I think just altered, yeah, a few higher boxes here, and then I just rotated it 180 degrees. So when I merge these two, you can see that yeah, we have this rectangle shape, square actually shape. So what I did here is the exact same thing. Like I copied it, but here I want to target all these boxes that height is equal to 2, not 1. So I create a group, and base group should be at P at Y, so positioned y-axis, more than 1. And group type should be points. So now you can see that we are targeting all the points that are higher than 1. Then we can add this group expand, and base group should be set to group 3. And I check this require primitive share edge. So now you can see that we actually have the whole primitive selected. And yeah, then I can just drop a delete node, set this group here to be group expand, and delete all the points. And now we can basically stack our previous, this one, we can stack it to this one. And yeah, then I added a transform, just translated it by 1 at y-axis. And now when I merge it, you can see that it fits perfectly. I also added poly bevel with a distance set to 0.02 and 2 divisions. And then I use this copy stamp. So the thing is, I'm adding 2 copies. Each copy is translated by 2 at y-axis and also rotated 90 degrees. So here you can see it. Basically, you can do it without copying, and then they will be absolutely like different. Each layer will be different, but I thought it's enough to just create 2 layers. So yeah, here we are with our cube, with our initial setup that we will be fracturing. So few things that I want to add here. I don't know if in the example it was done procedurally or actually they just stacked yeah, a few cubes, but it doesn't take too much time to just like create it by hand and not using any procedural methods. So yeah, and I think the result looks pretty interesting. So then, of course, we want to drop RBD material fracture, and for this one, the fracture here is plays really crucial role, because I will show you why we need really dense fracture here. And the denser the fracture here, the more realistic result you will get. And you can see it takes some time for it to compile. Here you can see that in primary fracture, I'm using simplex noise and scatter points is set to 300. In second scatter, I'm using sparse convolution noise frequency set to 0.5, and I'm scattering 10 points with a scatter seed set to 6. I also actually don't need these constraints. You can play with them, but in this particular case, I don't think that we actually need it. So we can uncheck the supply constraint properties. Yeah, for the chipping in detail, for this one, we are not adding anything. We could probably add edge detail and interior detail, but yeah, not for this example. For this action, when they jump out of their places, I'm using custom velocity that I set here in the attribute triangle. So here you can see that at v equals at n. So velocity direction, because velocity is vector and normals are also vectors, I can visualize this velocity with this get normals of these faces, and this is basically our normals where they are facing, and then I'm multiplying this value, and this value is basically from 0 to 1, because if we go to the geometry spreadsheet, here you can see we have our nx, ny, and nz, and basically I'm multiplying it by 50. This value 50 is more of a trial and error, or more of an experimentation thing, because the more this value is, the bigger will be the impulse with which these pieces will jump out of their places. Of course, we need to UV unwrap that. Spacing here is set to 0.1, because if we go to the set view and UV viewport, you will see how many tiny pieces we have here. So many. So yeah, let's go back to the perspective viewport and let's uncheck our normals. So now we, as usual, drop a RBD configure here. I need to transfer temperature and normals. That's very crucial, because we will drive our activation from the temperature of the Pyro source spread. And one thing that I wanted to limit here is this spin, because RBD, especially when you apply a pretty big force, these chunks tend to just like spin like crazy, you know. And yeah, that's why I checked the spin max limitation, set it to 10. So this RBD configure packs the geometry. So we have 16,216 packed fragments with 6 point attributes. Here you can see that actually n, it should be n here. So yeah, so now we wanna create this Pyro source spread. But the only thing is, I don't want it to go through the polygons, through the vertices, because again, if we visualize smooth wire shaded, obviously the one that's unpacked, you will see that we have a really irregular polygons here, and it will spread unevenly. So what I want to do here is, after RBD configure, I'm deleting everything but keeping the points. Keep points here is checked. And then I create the groups with these three spheres. So the group's called heat, and keep in bounding regions enabled, and bounding types set to bounding objects, points or vertices only. So these are points that here, when we create attribute called temperature, we created for the group heat, and default should be 0 and value should be 1. So these points here will be burning, and then we can go and do our Pyro source spread, set the visualization to temperature. In my case, cooling rate is set to 0, rate is set to 0.3, search radius to 1.1, max neighbor set to 18, and in the fuel, injection rate is set to 1.5 and post-burn rate is set to 0.7. But also in temperature change, I set the noise type to periodic Perlin flow and set the element size to 0.3. Also offset is set to 0.3 and minus 0.3 9. And this gives me this Pyro source spread. You can see how it all gets burned down. Obviously, I file cached this simulation, and yeah, that's how it looks. I file cached 210 frames. So then we can copy these attributes from these points to our packed geometry, because for the packed geometry, everything, every parameter is bind to the points. So if you want to colorize your packed geometry, you can assign color to the points, and the points will transmit that color to the actual packed mesh. So here we drop an attribute copy, and we want to copy normals, velocity, temperature, and diff rate. Diff rate is not used here, but just in case you want to bind, I don't know, maybe redshift shaders to the diff rate or temperature, we want to copy these parameters here from the points that we're burning. We want to copy them to our points from the RBD configure that don't have any temperature attributes, you know. Yeah, we obviously don't need this temperature here. Temperature needs to be there because we don't have it. So, but here in attribute copy, you will see that we already have temperature and diff rate. So we drop an attribute copy, and here we want to specify that we should match by attribute. An attribute to match should be name, because these points here have name, and these points here also have that name. So we can match by name and then copy the normals, velocities, temperatures, and diff rate. So then we don't actually need this attribute wrangle here, but yeah, then I added a bit of transform, because at that point I have already set my scene with the backplate and ground, so I needed to transform this piece here, because here in the .NET, if we dive inside, there are a few interesting things. I have actually added this cube here as a static object, so I needed a precise position of these two. That's why I dropped that transform there. So here we are using multi-solver. Here I would like to show you an example. So with the volume solver, you can directly plug SOP solver here, and it will act the same thing. So you will have the access to your geometry from the SOP. But here we want to use this multi-solver. So we drop an RBD packed object. Create deforming active objects should be set as an initial object type. Geometry source, first context geometry, because our transform is plugged into this .NET as a first context. We are overriding the attributes active, animated, deforming, and temperature. So here in the initial state, very crucial thing is to set the inherit velocity from point velocity. That's how these pieces will use the velocity that we have assigned to them before. Then we drop this multi-solver and we plug the rigid body solver and SOP solver here into this input here. To the rigid body solver, I think everything here is actually set to default. I haven't modified anything. You might need to increase the number of substeps though. Into the rigid body solver, into this middle input, I added the pop drag with a very little air resistance, just to kind of slow down all these small particles. But main magic happens here in the SOP solver. I have simulated 30 frames just to show you what's going on here. So the main thing is this active state. So active, yeah, basically determines if the geometry, if the point, and as you remember, points are representing packed geo chunks. So this is 1 point, and so on. So active could be 0 or it could be 1. Active 0 means that this point and this chunk does not receive or react to any forces. And active set to 1 means that it is a proper RBD object and behaves like a physical rigid body object. So what I'm doing here with this active is I'm binding it to the temperature, and basically this active is equal to the result of temperature being more than 1 minus frame divided by 120. So let me explain this in a bit. So active, if we want to set it active, we could just write by like expression like 2 is bigger than 1, and this results to true, and true results to 1, and 1 is active, so everything will be active. So what's happening with the temperature here is I'm basically writing that if temperature, and let's say the temperature is set to at that point is, I don't know, 3. If temperature is more than 1 minus, and we are at the frame, I don't know, 30 divided by 120. So 30 divided by 120 is 0.25. So this expression equals to 3 should be more than 1 minus 0.25. So it equals to 3 is more than 0.75. So if this expression is true, then we will have our chunk fly away. But if, let's say, the temperature at some point is, I don't know, 0.1, then if we are doing the same mass, 1.1 is not bigger than 0.75, so it equals to false. And then this chunk won't receive any forces, and also will not react to any forces. So that's how this expression works. And for the temperature scale, here I'm trying to clamp the temperature to from 0 to 8, clamped that to from 0 to 0.9, and P scale is set to 1 minus that clamped temperature. So the hotter this piece gets, and we are driving our temperature from that simulation that Pyro spread. So here you can see how these chunks actually become smaller and smaller and smaller, and become sort of a secondary RBD, sort of a chipping something, sort of these chips, and sort of copied to debris. So yeah, then I added the gravity, then I add static object, and yeah, that's basically it for the simulation. Of course, I file cached 210 frames, and you can see how. And also a cool thing here, so because our subsolver in our, sorry, yeah, let's not simulate that, but in our subsolver, after frame 120, everything becomes active, and I want to share with you why it goes like that. So whatever temperature could be will be more than 1 minus 120 multiplied by 120, and 120 divided by 120 is 1. So 101 will be at any point will be more than 0. So basically, after frame 120, whatever temperature is in our points, it will be more than 0. So after 120, and you can set it to be 150 or 90 or whatever, but yeah, everything becomes basically becomes active. So yeah, let me double check if everything is correct here. Yes, it is. So let's go back, get rid of this error, and my Houdini crashed at this point. So yeah, let's get back to our box, make sure that everything is working. So I want to cook these RBD fracture pieces. Yep, so our .NET is working fine, and yeah, file cached 120 frames, and you can see how all of these chunks become smaller and smaller, and some of them fall down, some of them are here, but you can see as we go after the frame 120, everything becomes active and it just falls down. Pretty cool effect though. So then we drop a dop import, and our .NET work set to this .NET object mask. We wanna select RBD backed object 1. We don't want to select this box, which is a static object there. And import style should be fetch unpacked geometry from .NET work. And yeah, then we just import RBD backed. So yep, our .NET is working correctly. And here is my mistake with the file caching. this .NET. So actually what you want to do is this file cache, it should be after our dop import. So here you want to just import this geometry, and then you want to file cache it, because right now the dop import will still try to solve our simulation. So yeah, make sure your file cache is after your dop import. But yeah, anyhow, we drop a normal, and then we have two redshift materials. So first material is this rock material, which applies to everything. And then we drop another material applied to the inside of these chunks, and I call it inside material. So yeah, that's it for the setup. I thought it's pretty easy to replicate, but yeah, looks pretty great. I don't know actually if I like the reversed version or the correct or base version better. Maybe you could let me know in the comments below. For the ground, it's just a cube with a poly bevel. For the backplate, it's just a grid, right? Like the super basic grid. We can talk about the dust particle setting. Let's just file cache 120 of our simulation. Not actually file cache, but cache it from RAM. And actually here we might need to yeah, get this file cache here. This goes here. Then we have our file cache. Yep, which is unpacked. And here in the dust, we can set this to be not the box, but the file cache. And I don't know which one we wanna use. Maybe file cache 5. Yep, we wanna use file cache 5. So, don't need these two groups, just need object merge, debris source. In the debris source, super crucial thing is to play with these scatter values, because you might have too many points here actually. But also remove unreleased and remove at live end should be checked. These are super crucial, because here, let me just hide the box, ground, backplate, everything. So if I leave this remove unreleased unchecked, you will see that we have all these points, but actually we wanna get only the released points, only these. And these are what we will be working with. So then we drop a popnet. Here, what we have is static object. Yeah, your default pop solver, pop object, source first input. In the source first input, I set it to be all points, burst it to 1, pop wind. Actually, this burst should be set as something like simulation frame less than 120 or no 180. And this should be correct, because we don't want to emit these points after everything settles down on the ground. So yeah, the pop wind amplitude set to 1, everything is default. Pop drag amplitude air resistance set to 1, everything is default. Static object, again adding this poly bevel ground, this box here, and in the popnet here, object merge, I set it to be only pop object, not the static object, because I actually don't need that box. But yeah, here you can see how it works. I have also added file cache, of course, here. So yeah, looks pretty good to me. And yeah, attribute wrangle after the file cache to set the p scale to be 0.01. And of course, I'm adding the color, and color here is bind to age. In the popnet here, you can see that in the source first input, I set the life expectancy to be 2. But here in the color, the range I set is actually 0 and 1. And yeah, color type run from attribute age from white to black. And we will bind this to the opacity in our redshift shader. So combined box and dust, if we go here to our material, yeah, I assume we will need to load 150 into the RAM just so I can show you how it looks like on the different frames. Yep, so we have our 150 frames rendered here, and let's add the backplate and the ground, and yeah, that's our setup. Let's talk about the lights, materials, and cameras. So I wanna add a redshift render view here and hit render from the camera 1. Yeah, this is our beautiful render. So before we start, I want to say that you will need to add pretty strong bokeh here, because we are not adding motion blur here. I actually added motion blur in post with a real smart motion blur in After Effects. But yeah, this bokeh, I would say without that, the effect is not looking that good. But yeah, we have 3 lights here. Let me switch one by one. So this is our main light, which shines from this side, large area light. So then we have another one, which I keyframe from 0 to 60 in the range of frames 1 to 60, and it hits it from this side. And then we have the last one, which here in the objects, I have ticked this enable light mesh associations and lights enabled for OBJ box. So only for our box, we have this area light, which is located at the other side. If I could show you, if it's here, is this redshift light. And if I enable it to be 100 in the intensity, it's basically a backlight, but it should be subtle in my opinion, so it's set to 10. And if I enable all of them, yes, we see this beautiful render. So for the materials, here are my materials. Again, I'm using noises to generate procedural bumps. There is a tutorial on my Patreon about bump maps from noises, so check it out. I won't be going in too much detail for this one. But for the dust, we grab this color data attribute from the particles and we feed it into the overall opacity. I have this warm gray color as a diffuse color for my particles, and they are pretty roughness set to 0.89. For the inside material, I'm actually using this milky coffee preset from the Redshift. Then RS noise is plugged into the bump map, and that is added to the bump of this milky coffee. For the rock material, again, I'm using 2 noises. One is fractal and one is maximum turbulence noise. I mix these 2 bump maps with a blended weight of 0.451, and yeah, feed it into the material, and this is my rock material. And then I have this displaced turbulence bump map noise, which you can probably see here. This is a more or less like a plaster material without that much of a bump. So yeah, I think that's it, guys. For the composition, I aimed for something similar in that reference, but because I'm rendering these vertically, I needed to adjust it a little bit. Alright, so that's all. I really hope you enjoyed it, you learned something new. If you have any questions, please feel absolutely free to reach out to me in Discord, in our Cozy Place community, or here in Patreon, and I will be back next week with another tutorial. Bye!